Question 6. What convention do we use for electric charge when a glass rod is rubbed on a piece of silk? Do we say the glass rod gains a positive charge, a negative charge, a clockwise charge, or an anti-clockwise charge? Now, right away we can see it's not going to be C and D. Electric charge is a scalar quantity. It's a number. It doesn't point in any direction. So this means that directions don't make sense. We can't say that the charge is clockwise or anti-clockwise. Our options then are a positive charge or a negative charge. Now of these two, Benjamin Franklin was the one who arbitrarily decided which was right. The one that he picked was saying that the glass rod gains a positive charge. Question 7. How do charged objects interact with each other? Do they attract each other if they're oppositely charged? Attract each other if they're similarly charged? Do they attract other things if they're positively charged? Or do they attract things if they're negatively charged? Now, if you have a rubber glass rod on a piece of silk, you'll notice that the glass rod can attract things. So does that mean that the answer is C, positively charged objects attract all other objects? Well, no, it doesn't, because if we bring two of those glass rods together, they repel each other. And that gives us a hint as to what the answer could be. So it can't be D, negatively charged objects will repel other negatively charged objects. It can't be C, because positively charged objects will repel each other. It can't be B, because if we have similarly charged objects, then they'll repel each other. The last option then is A, oppositely charged objects attract each other. And so this is the correct answer. Opposites attract and like charges repel. Question 8. Name a pair of materials, other than glass and silk, that can be rubbed together to produce an electric charge. Now there's a whole number of these, so I'm going to name a few. So one possible answer is ebonite and wool. You might perform this experiment in class. If I recall correctly, the ebonite picks up a negative charge and the wool picks up a positive. So it's the opposite for glass and silk. Another way that we can get a static charge is, of course, amber and fur. The amber is what electricity is named after. Carpet and rubber-soled shoes are the cause of many an accidental electric shock. Dry hair and a plastic comb can sometimes cause crackling or sparking. So these are all ways of producing charges. Any spark that's produced by static electricity is a result of an unbalanced charge between the two objects. Question 9. How does a battery separate positive and negative charges to produce electricity? You don't need to get into too much detail. So in chemistry, you can learn about how a battery works and exactly what the chemical reactions are that will produce a discrepancy between the protons and the electrons of a substance. But we don't really cover that in physics, so our answer might look something more like this. A battery separates positive and negative charges with a chemical reaction that occurs inside the battery. We don't need to get any more complex than that unless we're doing chemistry. So the reaction usually involves two different metals, as well as a chemical called an electrolyte. Question 10. When a substance gains electrons so that it has an excess of electrons, it becomes negatively charged. Fair enough. How does a substance become positively charged? At first, it's tempting to write a similar sort of sentence to the first one. We can say that it must gain an excess number of protons from somewhere else. But this isn't true. Instead, we lose electrons. So a substance becomes positively charged when it loses electrons, so that it has a deficiency of electrons. This means that we'll have more protons than electrons in the substance. We do not gain positively charged particles. We simply lose negatively charged particles. And if we're losing a negative charge, well, when you subtract a negative, you end up with a positive charge. So that's the end of the questions. In this section, we've learned about the history of electricity, in particular static electricity, and we've looked at what can cause electric charge. Negative electric charges are caused by an excess of electrons, and positive electric charges are caused by a deficiency of electrons.